Hi AP Physics, Nicole here, and I'm going to be teaching you how to do an AP problem. So if you go into your packets or look online, you're going to be looking for the 2010 AP Physics C free response question, Form B. Make sure it's Form B, because if you don't get Form B, then you're not going to get the right problem. So you should be looking at a diagram that shows you a spring scale, actually two spring scales, attached to two objects. One is placed in the air, and one is placed in water. Let's read the question. An object is suspended from a spring scale, first in air, then in water, as shown in the figure above. The spring scale reading in air is 17.8 newtons, and the spring scale reading when the object is completely submerged in the water is 16.2 newtons. And we have the density of the water equal to 1,000 kilograms per meter cubed. Now when I draw on my paper, I like to label everything. This way when I'm getting into the problem, I don't get confused. So I'm going to label the density of the water as rho. This way I know what the variables stand for. So the first question, part A, asks us to calculate the buoyant force on the object when it is in the water. So I'm just going to zoom out here so that you guys can see my paper. Now, it's asking us to calculate the buoyant force. So, most of us would say, oh, buoyant force, that equals to rho times volume times gravity. But here, buoyant force is simply subtracting the values that they give us. So let's label our diagram. They give us that when the spring scale has the object attached to it when it's only in air, it reads 17.8 newtons. When the spring scale has the object attached to it and it's completely submerged in water, it reads 16.2 newtons. So, all we have to do is say that the buoyant force, or FB, is the distance, or actually the difference in the two scale readings. So FB is equal to 17.8 newtons minus 16.2 newtons. Help if I pointed the camera down so you can see better. Let me zoom in. And simply FB equals 1.6 newtons. Easy as that. It's not as complicated as you think it is. Part B. Part B asks us to calculate the volume of the object. So, if you think about the formula for buoyant force, FB equals rho VG. It has volume in it. So simply, all you have to do is plug in the numbers that you already know. Now, we know that the buoyant force is 1.6 newtons, and you might think, oh, what's rho? They give it to us as 1,000 kilograms per meters cubed. We're finding the volume, and then we need to find gravity, which we should know as 10 meters per second squared. Okay? And then when we multiply everything out, we get the volume to equal 1.6 times 10 to the negative fourth meters cubed. Simple. Once you break a question down, it's definitely not as hard as you thought it originally was. So now let's do part C. Calculate the density of the object. So to find the density, you need to know, obviously, what the formula is. I'm going to teach you a trick here that you might have learned when you were in 7th grade. I seem to have remembered it, and it definitely helps me on certain tests. You make a triangle, and you break the triangle up into 3 parts, like so. And then, I like to write D, or in this case, you could write rho in the bottom left-hand corner, M on the top portion, and V in the bottom right-hand corner. And you can remember it going as DMV, like Department of Motor Vehicles. That's how I remember it. But if you cover up the variable that you're looking for, so let's say we're finding density, you know that the formula is mass over volume. If you're finding mass, you know that the formula is density times volume. So just a simple, stupid little trick to remember some things. So now, back to finding the density. The easiest way to solve for it in air, because you don't have any other forces applied to it, and you can use the springs that they give us. So when you're using springs, you can use sigma F equals ma. Everything in physics comes back to everything else. So think about other concepts and topics that we've learned before and bring it back to the current topic. So, since we said we're solving for it in air, the force is 17.8 newtons equals mass, what we're solving for, times acceleration, which is 10 meters per second squared, or gravity. And when you multiply it out, you get mass is equal to 1.78 kilograms. But they're not asking us for mass. They're asking us for density. So, all you have to do is go back and find that density, or rho, equals, go to the triangle, mass over volume. Simple. We have all those variables. So mass is 1.78 kilograms, and volume is 1.6 times 10 to the negative 4th meters cubed, which we found up here. And when you multiply everything out, you get that rho, or density, equals 11,125 kilograms per meters cubed. And there you have your density. Now, part D says, how would the absolute pressure at the bottom of the water change if the object was removed? So let's say we're back up in our diagram. Excuse my old and rickety tripod. The object is in the water. What would happen if we took the object out? Well, to start with, when the object is placed in the water, there is an added weight pushing down on the bottom of the container. And since there's added weight on the bottom of the container, there is more pressure. However, when you remove the object, there'll be less pressure on the bottom of the container. Therefore, the absolute pressure will have decreased. So, we go back to our problem. We can check off the middle box. It would decrease, and then it asks us to justify our answer. So we'll have to write a response. I'll shorten it now because I basically just explained it, but when there is an added weight, on the container, there is going to be more pressure on the bottom. But then when you take away weight, there is less pressure. It all has to do with the amount of water being displaced, the volume of the object, and stuff like that. But all you basically need to know is that more weight, more pressure, less weight, less pressure. Okay, so that is the AP problem that we went over for now. Again, it was the 2010 AP Physics B question from number 6 from Form B. I hope you guys have a great day, and I hope this helps you guys out.